have an impact, you have that instant in which all this energy is converted to heat. But that's only part of it. You then have the vapor that expands and heats up the atmosphere as well. So now you are no longer dealing with just the point of impact and the vapor that's created there. You now have material that's expanding. Eventually, some of that material is expanding and goes out of the atmosphere of the Earth, then comes back down. During the time when it comes back down, it's generating more radiation so that you have the heat of the impact, then you have the material, the vapor that heats the atmosphere, then you have ejecta that returns to the surface of the Earth. And as it goes through the atmosphere, it will create enough energy to literally fry, completely combust any living organism that would exist.
The total evaporation event that occurred around 4 billion years ago was catastrophic. Water as well as salt deposited on the ocean floor evaporated. There are microbes that actually like heat, but not heat like this. Dr. Sleep of Stanford University looked long and hard at early life's survival capabilities. He thinks that he's found an answer. There was a part of the Earth where life could sustain itself, and this was deep below the ocean floor. This graph shows the temperature distribution in the subsurface of the Earth. The red area is the heat from the Earth's core. Nothing can survive in this region. Green are regions below boiling point. Blue are regions just below 50 degrees Celsius or 122 Fahrenheit. Life could survive in the blue zone, the Goldilocks zone, as Dr. Sleep calls it. It has been estimated that the temperatures on the surface of the Earth would have reached as high as 2,000 degrees Celsius, over 3,500 Fahrenheit. What the researchers wanted to know was how deep would the heat penetrate and how fast could it travel down into the Earth? Would the heat from above meet the heat from below? The heat from above travels slowly and steadily, about 1 meter or 3 feet every year. The simulation showed that there will always be regions where life could survive.
Any organisms that are living deep underground, like 1 to 2 kilometers thick, will be fairly safe. The heat pulse doesn't last long enough for the heat to propagate down to that depth. It's a little like when you cook a turkey. You can't cook a turkey in your oven in 1 minute. If you try to do that, even if you get the outside very hot, the inside will still be cool. We have the temperatures here. At the ridge axis, things are relatively hot. As we get away from the ridge axis, it's relatively cool. An ordinary organism, you want to be here in the blue.
If life were present 3.8 billion years ago, then the life that we have on Earth now would have descended from life that liked higher temperatures, or was more able to survive high temperature waters, and was not photosynthetic.
However, early life needed water, and the water on the surface of the planet was gone. Was it possible to sustain any sort of life in the rocks deep below the Earth's surface? Here in South Africa, that question has been answered. Gold brings wealth to a country, but the job of getting that gold is dangerous. This is one of the deepest man-made shafts in the world. It drops down over 2 miles below the surface. And it's not just the miners who take the long trip below.
Luckily, we
Dr. Esther van Heerden of South Africa's Free State University is researching the survival of life deep within the Earth. Her findings and those of the research team are astounding. Before these shafts were excavated, there was nowhere for scientists to search. It's dangerous down here. For every half mile underground, the temperature goes up by 10 to 15 degrees. And there is the constant danger from methane. High levels of this gas would cause an explosion, so it's frequently monitored. Even so, methane is constantly leaking from the rocks. Yet life actually was found here. Groundwater is seeping from the rocks, and the surface of the mine wall is covered by a thick film of white and black. This is a mat of various forms of bacteria, species not found on the Earth's surface. Here they do not use oxygen. They are anaerobic. But research shows that many of them still possess the genes for oxygen respiration, useless down here. Perhaps this is evidence that these microorganisms once lived on the surface, only to migrate to these depths, perhaps to escape the heat of a total evaporation impact.
Initially, we thought that life only existed 2 feet from the surface. We now know that through access through this deep mine subsurface project, that there are organisms as far as 3 kilometers underground. Had we had access to other deep subsurface environments, surely we might find traces of organisms there, which might indicate the same pattern as we are seeing here.
This deep underground world has been a refuge for life for possibly billions of years. So far as we know, when life first formed on the planet, it lived in the oceans. It spread out, and some life forms clearly moved down into the dark subsurface of the Earth to quietly remain in cracks and in rocks, residing in waters heated by the Earth's inner mantle.
If we look at these organisms living in these environments, they have adapted to survive. Their main aim is just to survive and sustain themselves. Surely, as things change, new organisms, or these organisms, will change and adapt to make sure that life is sustained on the planet no matter what happens.
To survive is life's objective. And sometime after the total evaporation event, life must have once again returned to the surface.